In question 16, we are told that a pendulum consists of a small object on the end of a light string. Okay, when the object is set in motion, it oscillates with simple harmonic motion with negligible damping. The max potential energy of the object at max displacement max displacement x is E. Okay, so the first thing that we must recall is that the relationship between max potential energy and the max displacement. So using that notation, we have E, which is equal to half m omega square x square. All right. So the total energy, or rather the max potential energy, max PE, is proportional to amplitude square. All right. So the question then tells us that the pendulum is stopped and started again, and now the max potential energy is reduced by E over 4. So the important word here is reduced by E over 4. This means that the new max PE is going to be equal to 3/4 of E. Okay, so if we have E, which is proportional to x square, okay, and our new E is going to be proportional to our new amplitude square. If we take left over left and right over right, we have the new E divided by the old E, which must be equal to the new amplitude square over the old amplitude squared. Okay, but we already know that our new E is going to be 3/4 that of the old E. So we have 3/4 is equal to x prime square over x square. So if from here we make x prime square the subject of our formula, okay, we have 3/4 x square, and from here we square root both sides. We have root of 3 over 4 x, okay, and this gives me around 0.866 x. So from here, this leads us to our next trick in the question. The question then tells us what is the change in the amplitude of the oscillation. So the change in the amplitude is going to give us x minus of our new amplitude. So we have x minus 0.866x, which is going to be equal to 0.134x. So our answer to this question is actually A. So bear in mind that this question has two tricks over here, and the first trick is the reduced by E over 4, and the second trick is the change in the amplitude of oscillation. Okay.